Good morning, students. Chapter 6, Work, Energy and Power. Yes, what is work? Work done by constant force, work done by variable force. Yes, we have discussed. Energy, kinetic energy, potential energy. In potential energy, gravitational potential energy and elastic potential energy that we have discussed. Also, what is mechanical energy? Then law of conservation of mechanical energy. Okay, so yes, we have discussed about work, energy. Now it is time for power. So yes, what is power? First of all, what is power? Yes, we know work done. Okay, to move, or if it is on block A, it is displaced from this point A to B with the help of some external force. Okay, and displacement is B. So yes, W is equal to here it is F. Yes or no? W is equal to here it is F. Okay. Let if I have one person 1. Okay. It is work. Yes or no? This block A is displaced from point A to B. By applying force F, displacement is D, then work is F into D. Okay. If for this work person 1 takes 1 hour. Okay, and for the same work, if person 2 takes 2 hours. Clear about this? Work is same. Hello, again, work is same. I want to displace this block from A to B. Person 1 takes 1 hour, person 2 takes 2 hours. So yes, here work is same, but rate of work means time duration during which this work is done is different for this 2 person, is different for this 2 person, and yes, it is important one. Okay, work, you know what is work. Okay, but rate of work, okay, that work is performed, it is work done during which period, it is also important. It is also important. Okay, if that is one video of physics lecture that is of 25 minutes. If some students complete that video in 1 hour, then yes, very good. But if some students takes 3 hours, then it is not good. Why? Because work is same. Someone is taking proper time. Okay, that is 1 hour, but someone is taking 3 hours. So it is very long time. It is very long time to perform the same work. If you take more time, then it is not good. Okay, so here it is work, we know. What is energy, we know. But another important quantity is power. Okay, what is rate of work? That work is performed during which time? Okay, so yes, there is importance of work. Here I can say this person 1 completes that work in 1 hour, and this person 2 completes that work in 2 hours, which this person is fit and this person is not fit. So power of this person is high and power of this person is less. Clear about this? So that is importance of power. If you are on ground floor, okay, if 2 students are on ground floor, one person takes half hour to reach 4th floor and another student takes only 15 minutes, then yes, work is same. You have to go through the same height. That is ground floor to 4th floor. But one is taking 30 minutes and another taking is 15 minutes. So it means their powers are different. Their ability to do work in some time is different. Clear about this? So here, that's why we have to study what is power. Okay, what is power? Time rate of work done is called power. First of all, I will write what is average power. Average power is defined as W is equal to average power is defined as P average is equal to W upon average power. P average is equal to W upon T. Okay, another one, instantaneous power. How to define instantaneous power? P is equal to dW upon dt. P is equal to dW upon dt. So yes, it is equation of power. Average power P is equal to W upon T, work per unit time, work per time, work per time. It is also work per time. Now we know that W is equal to, it is F dot D. So if I put value of W in this equation, P is equal to, it is D upon dt. What is W? It is F dot D. It is F dot D. Yes or no? Yes or no? Yes. If F is constant, then I can say it is F dot D upon dt of D, where D is displacement. What is differentiation of time with respect to displacement? It is velocity. So yes, here it is F dot D. So it is another equation of power. Power P is equal to, it is F dot V. Power P is equal to, it is F dot. Clear about this? So yes, average power P average is equal to W upon T. Instantaneous power P is equal to dW upon dt. And another equation of power P is equal to, it is F dot V, which is used to solve some questions. Okay. Now we will talk about units of power. First, power from this equation. Okay. The power P is equal to W upon T. So yes, what is unit of power? Unit of power. What? Its unit is work. Its unit is joule, and T its unit is second. Or I can also write as work is equal to Newton into meter. Joule is equal to Newton into meter upon second. Or in the memory of great scientist, what? It is also called unit of power. Unit of power is watt, and it is indicated by W, capital W. Clear about this? So yes, it is unit of power. That is watt. Another unit of power they are given. Yes, 1 horsepower. 1 horsepower is equal to, it is 746 watt. It is 746 watt. Clear about this? And yes, if you know power P is equal to W upon T. Yes, power P is equal to W upon T. If I make W as subject, then it is P. Yes or no? Then it is P. Then yes, this W I can refer as energy consumed. It is power P, and it is time. Clear about this? Okay. So yes, if you know that in our electricity bill they count rupees, or they count money with respect to unit. So what is unit? Okay, per unit it costs like this. Okay, per unit it is this much rupees, per unit it is this much rupees. That is different for residential area and for industrial area. Okay, so yes, what is unit? Okay, if 1 kilowatt power, power is 1 kilowatt for 1 hour, okay, it is power and it is 1 hour. Then energy consumed is called 1 kilowatt hour is equal to, it is also called unit. Clear about this? If 1 kilowatt energy, if 1 kilowatt power, okay, is used for 1 hour, then energy consumed is called 1 kilowatt hour, and it is also called unit. Okay, so how to find that value of unit? See, here it is. We know that W is equal to, it is PT. So yes, W is equal to P power 1 kilowatt for time 1 hour. So 1 kilowatt means it is 1 into 10 raised to 3 watt into 1 hour means 3600 second. So how to write this? See, W is equal to it is W is equal to it is 3600 into 10 raised to 3 into 10 raised to 3 watt second. It is watt second. Clear about this? Clear about this? Okay, so yes, here it is 10 raised to 3 1 2 3, so I can write it as 3.6 into 10 raised to 3 into 10 raised to 3. What means it is joule per second. Here it is second, so second, third, so it is 3.6 into 10 raised to 6 joule. Clear about this? Clear about this? And it is called 1 unit energy. It is called 1 unit energy. So in short, if I want to write what is 1 unit energy, so 1 unit is equal to 1 kilowatt hour is equal to is 3.6 into 10 raised to 6 joule energy. 3.6 into 10 raised to 6 joule energy. Clear about this? Clear about this? Okay, so yes, it is one question. It is one question. What is power? What is power? Yes, power is rate of work done. Power is rate of work. Clear about this? So yes, what is work? We know that. What is energy and what is power? Okay. Okay. Next question is exercise 6.25. See, two inclined frictionless tracks, one gradual and another steep, meet at A from where two stones are allowed to slide down from rest. Will the stones reach the bottom at same time? Will they reach with the same speed? Also find time and speed. See what is question. Here we have one figure. See, you are given two inclined frictionless tracks. First track, second track. Okay, they meet at A. Yes, they meet at A. Okay, so yes, from where two stones are allowed to slide down from rest. Two stones are allowed to slide down from rest. Yes, two stones from point A. One slides in this direction, okay, and another slides on this one. Okay, so yes, you have to find, will the stones reach the bottom at same time? Will they reach there with same speed? Height is given, theta 1 and theta 2 angles are also given. See, here. Initially they both are at point A. Yes or no? Yes. Initially they both are at point A. If I am taking this surface as reference surface, if I am taking this surface as reference surface, if I am taking this surface as reference surface, okay, it is reference surface. Then from this reference surface, point A, it is at height 10 meter. It is at height 10 meter and in rest condition. And in an rest condition. Okay, so yes, here its kinetic energy will be 0. Obviously, here its kinetic energy will be 0. But as it is at some height, it will have some potential energy. It will have some potential energy. Now see, this slope AB block is sliding down, and it will come to this point. What? Yes or no? So yes, at this bottom, as it is reference surface, its height will be 0, its potential energy will be 0, but it will have some kinetic energy. It will have some kinetic energy. Yes or no? Yes. Clear about this? Similarly, this object will slide down on this surface, and it will again come to this point C, that is bottom. Okay. So see what happens. Initially, both objects, they are at same point, that is A, means at same height, means potential energy of both objects same. Yes or no? Yes. Now they will slide down on different slope, but they will reach the same bottom. They will reach the same bottom. Yes or no? So yes, what happens here, we can say according to law of conservation of energy, when these two objects slide down on different slopes but to the same level, okay, their speed will be same. How? See here, according to law of conservation of energy. According to law of conservation of energy. See, here it is. how to apply law of conservation of energy for slope AB. And here I will write for slope AC. This object is initially at point A. So what is mechanical energy at point A? E. Then it will reach to point B. Then what is mechanical energy at point B? It is T. At point A, you are given that this starts from rest condition. Okay. First of all, I will write what is E and AB. E means it is KA plus UA is equal to, here it is KB plus UB. Yes or no? Yes. EA initially at this point it is in rest condition. Rest condition, so kinetic energy is 0. What is UA? Means potential energy. It is mgh. Clear about this? At bottom, at this point we have to find its speed. So I am assuming its speed. Okay. Let it is half m v square. Its speed is v plus UB. What is potential energy at bottom now? Potential energy at bottom is 0. Simple. So we can easily say kinetic energy of potential energy of object is converted in kinetic energy. Potential energy of object is converted in kinetic energy. Potential energy is converted in kinetic energy. Simple. So yes, m cut. If you make V a subject, then V is equal to, it is under root 2 GH. It is under root 2 G 9.8 H. It is 10. So it is here 196. And what is square root of 196? What is square root of 196? It is 14 meter per second. Clear about this? What will happen for AC? See here for AC. EA is equal to EC. EA is equal to EC. KA plus UA is equal to KC plus UC. Clear about this? Clear about this? Okay, here it is KA plus UA is equal to KC plus UC. Then what happens? See here. Then what happens? KA, kinetic energy at point A. At point A, it is in rest condition, so kinetic energy is 0. Point A, it is at height h from this bottom, and it is mgh is equal to Kc. At bottom, it will have some speed. So yes, let it is half mv square. Plus UC at bottom, this potential energy will be 0 because 0 height. So yes, again we can say potential energy is converted in kinetic energy. So yes, m cut V is equal to under root 2 GH is equal to under root 2 into 9.8 into 10. It is under root 196. So it is equal to, it is 14 meter per second. So yes, will they reach that with same speed? Yes, they will reach bottom with the same speed. Clear about this? Clear about this? Okay, but time, what about time? What about time? How to find the time? See, yes, they are starting from this point A, rest condition. At bottom, we know that speed. Okay, then how to find time? We know initial velocity, we know final velocity, and we have to find time. So yes, we can use this equation. That is V is equal to V0 plus 80. So V is equal to, it is 0 plus 80. So T is equal to, it is V upon A. T is equal to, it is V upon A. But what about A? What about A? Acceleration. A, acceleration. Yes, how to find acceleration? See, here it is. It is first object on downward direction. Force acting is mg. Two components like this. Okay, as this angle will become 30, it is mg cos 30. It is mg sin 30. It is normal force and it is normal force and hello students, you know, for a smooth surface, what is acceleration parallel to surface? G sin theta. What is acceleration parallel to surface? G sin theta. So yes, here. This A we can replace by G sin theta. This A we can replace by G sin theta. Yes or no? Yes, you know what is acceleration parallel to surface. Okay, acceleration parallel to surface. Acceleration parallel to surface. A is equal to, it is G sin theta. Clear about this? So yes, here it is T1 for this first object. It is, suppose it is general equation. T is equal to, it is V G sin theta. T is equal to V upon G sin theta. So for first AB surface. Okay, P1 on this surface AB. What is velocity at bottom? It is 14 divided by G 9.8. Okay, and sin theta means sin 30. Sin theta means sin 30. It is 14 divided by 9.8 and sin 30. What is value of sin 30? Sin 30 it is just 1 by 2. So yes, if you calculate this, you will get your answer 2.86 seconds. 2.86 seconds. Okay, so simple. We know what is value of V for AB. Put value of V, put value of G, put value of sin theta. Now for AC. For AC slope, T2 is equal to, here it is 14 upon 9.8 and here it is sin 60. So is equal to, it is 14 upon 9.8 into sin 60 means it is root 3 by 2. And if you calculate this, you will get your answer 1.65. 1.65. Clear about this? Clear about this? So yes, you have this 2 times T1 and T1. From this you can say that T1 is greater than T2. T1 is greater than T2. Means it will take more time and it will take this. Okay? So yes, as initial height is same and final position of two objects, they are on ground. So yes, that speed at bottom is same. That speed at bottom is same because it is same level. Green and C is same level. So that speed is same. Clear? But yes, as acceleration here for this block acceleration is G sin 30. For this block acceleration it is G sin 60. So as acceleration parallel to surface is different. Acceleration parallel to surface is difference. Time taken by objects to reach bottom also different. Clear about this? So yes, it is one question which is again based on law of conservation of energy. Clear about this? Yes, dear students. Watch videos regularly, make notes regularly. If you have any doubts, then yes, contact me to solve your doubts. And yes, do like, share, and comment.